So here we have a problem involving a car being towed by a tow truck. So what we want to find is the tension force of this rope on the car if it's accelerating at 3 meters per second backwards. So let's solve this. First, we start off with a free body diagram. We'll start off with this ball representing this car. So first we have the tension force. First we have the tension force pulling it back. Because it's accelerating, this force is greater than the force of friction pulling it back because it's accelerating in the direction of this tension force, which means that this force is larger than the friction force. Then we also have a normal force since our car is in fact on a surface. And of course we have our weight. So now we have our four forces. So let's start off with the sum of our y forces. So the sum of our y forces is equal to, so we'll say that up is positive and down is negative. So is equal to the normal force minus the weight, which is the normal force minus mass times the acceleration due to gravity. And since there is no vertical acceleration, that means that since F is equal to ma, our y force, or sum of our y forces is 0. Which means that our normal force is equal to the mass times the acceleration due to gravity, or the weight of the car. So now we're going to do our sum of x forces to find the tension force. So since it's accelerating in this direction, this is the direction of it positive. This is what we're going to say is positive because it's accelerating in that direction. So this is equal to T minus the friction force. T minus the kinetic friction. And kinetic friction is equal to the coefficient of kinetic friction times the normal force. So this is really equal to T minus mu k normal force. And our mu k is 0.3. So what we can do now is we can plug in Fn equals mg by saying that the sum of our x forces is equal to the tension force minus mu k times the mass times the acceleration due to gravity. And so now the only thing we have to do is solve for t. First by saying that our sum of x forces is the mass times the acceleration, because F equals ma. So this means that t is equal to ma plus mu k mg, which means that our tension force is equal to the mass times the acceleration plus the coefficient of kinetic friction times the acceleration due to gravity. So this means that the tension is equal to 1,000 kilograms, which is the mass of our car, times the acceleration, which is 3 meters per second, plus 0.3 times the acceleration due to gravity, which is 10 meters per second squared. Which now we just solve for tension is 1,000 kilograms times 3 meters per second plus 3 meters per second squared. 3 meters per second squared, my bad, because it's acceleration, it's meters per second squared. 3 meters per second squared plus 0.3 times 10 is 3, so that's 6 meters per second squared is equal to 6,000 newtons, since a newton is a kilogram meter per second squared. So our tension force is 6,000 newtons.